Hello, Java fans. It's Evren. I'm the co-founder of Turkey Java community, and today we have another great guest, Nikolai from Oracle Developer Advocate team. He is with us. Thank you again, Nikolai, for accepting our request and being with us today. So
Sure.
he has, yeah, he has a great topic. He will talk about Project Amber, Loom, Valhalla, and Panama. And Nikolai, so the stage is yours. You can start.
Yeah. So thank you, everybody. Thank you, everyone, for the invitation. By the way, I really appreciate it. I would love to be even closer than just remotely from like about 3,500 kilometers away. I guess, or more like 3,000. I'm not entirely sure. But I was
Something
actually
like
in
that.
Istanbul earlier, like last year, and maybe there's a chance that I'll be back next year. That would actually be pretty cool.
Why not? Why not? You are always welcome. You know.
Exactly. Yeah, that would be great.
It's really
So as
nice
everyone
to
said,
listen.
sorry.
It's really nice to listen you every time, Nikolai.
Yeah. Thank you. Right, so as everyone said, I'm a Java developer advocate with Oracle. So it's not only my hobby, it's also my job to tell you about all the cool things Java. And so I will give you the presentation, as I said, on Amber, Loom, Panama, and Valhalla. And then afterwards, right, if you have any questions, just put them into the chat. English or Turkish, no problem. Everyone will translate the ones that I can understand. And then we can... as I said, like it's 4 different topics largely, so we're gonna try to block the question. Get the questions together, so all the Amber questions, for example, come at the end of the Amber section. But that aside, yeah, I think we can get going, right?
Yeah.
So I need my presentation on the screen. There we go. There it is. Great. Okay. Good. So let's get going. Very important. The slides are already online. You can go to slides.nipafx.dev and you will find Java Next on the top right. And then you can follow along as you go through it. Just as a tip, hit the question mark on your keyboard in the beginning. You will need this, otherwise you will have trouble navigating. Trust me. Hit question mark to see this. I will, show you that later as well. Okay. Anyway, so let's get going. We'll start with Project Amber, and the goal of Project Amber is a smaller, productivity-oriented Java language features. And all of these are links here to the project, the wiki, the mailing list. So you can check those out. You can check those out if you have the presentation in front of you. It was launched in March 2017 and is led by Brian Getz. And the motivation is to tackle some of the downsides that Java has. So sometimes Java is cumbersome. It might require some boilerplate. And the main reason is that in specific cases, it isn't really that expressive. You can sometimes not express simply what you want to do, and that's why you have to express it with more code, with more boilerplate, with more indirection maybe. And the goal of Project Amber is not to identify a single problem, give a simple solution, then be done. That's the normal way these projects go, right? If you think back to Project Jigsaw, which introduced the model system, Project Lambda, which introduced lambdas and streams, those projects are essentially done, right? The mailing lists are dead, nothing happening there anymore. They're done. And that makes sense for them because they identified a specific problem that had a one-shot solution. But the goal of Amber is more to be a solution factory, to look at Java and find places where there is fundamental improvements to be had. It's not so much about like small, like little syntax improvements, syntax sugar that just improves coding by like 1% or 2%. It's looking at deeper problems of the language and tries to tackle them. And it will continue to do so into the future. And already delivered a bunch of things in the past. So going from bottom to top here to start with the oldest things that got added. That was local variable type inference in Java 10. We got a bunch of improvements to switch, pattern matching, records, and sealed types that kind of belong together. I get to that in a second. We have text blocks in between here. And all these numbers, when I mention them, like in Java 15 for text blocks, for examples, that was the version it was finalized. So since Java 15, the feature is done and can be used in production. And you could already experiment with it a version or 2 before. So as I mentioned, a bunch of those features can be bundled together. Switch expressions, pattern matching, records, sealed types, they belong under the umbrella of pattern matching. Now, these features are valuable individually, right? Just records are great, and just sealed types are great. It's not that they only work together. But when they work together, they are more than the sum of their parts, and they unlock a new style of programming in Java. The programming style overall is not new, but it's new that you could do it this well in Java. And that's one way to see that, one way angle from which to view this is through the lens of the data-oriented programming paradigm. And I could go into that now. We could talk about pattern matching a lot. And the reason why I don't is, first of all, there's I made this video online that you can see, data-oriented programming. That's the Inside Java newscast number 29. But more importantly, there's already a lot of people out there giving good content on that, giving great talks on that. There's blog posts and everything. So I don't think that's the most value I can provide here today. So instead of going over that again, and even if you don't know it yet, as I said, there are tons of sources online like this video that you can take a look at. What I want to do instead is I want to brought you something else, something that is also done by Project Amber at the moment, or being worked on, I should say, by Project Amber at the moment, and that we might see this year if we're lucky. And this deals with string composition. Okay, so let's talk about string compositions. What I'm doing here is I have two string properties, two string parameters called property and value, and I want to put them together into a string query, into this SQL query, right? So one way to do that would just be to use plus. And another way to do that would be to use these placeholders and then use the the string formatting method. And that's okay, I guess. Like it's cumbersome, so it's not great. It's not really very readable, and also comes with a free SQL injection. So clearly there's some improvement to be had here. So why couldn't we do something like this? So I made the syntax up, almost. We'll see later, it's not entirely made up. Other languages often use a $sign here, where you can use $, curly braces, and then you put the value of the, I said parameter earlier, which is not correct. Variable, what the hell? Variable is the term I'm looking for. So you can reference the variable here. Often you can even do short expressions. You can technically do long expressions as well, but you want to keep this readable. But you could maybe do some math in here. You could call a method in here. So this here property, that's not text, right? That's a reference back to the variable from earlier. And as I said, other languages like JavaScript, for example, allow this like $, curly brace, and then you embed it here. And that's great, right? It makes it much more readable, much faster. Now you can get your SQL injection with less code. So clearly, it's an improvement, but is it an improvement in the right direction? I mean, yes, it makes it easier to, put variables in strings, but putting variables in strings is not a task that stands on its own. It's just a small step in a larger process. And usually the process is to create a language that we want to pass on to another system, right? SQL to pass to the database, HTML, XML for the browser, JSON for some other maybe some backend, some other service that's online, YAML for configuration, whatever. So we're not just creating strings, we're usually creating structured language. And the structured language all has individual rules like validation, sanitization, things that you need to be aware of to properly create a string of that type. And this is where string templates come in. There's a JEP for that, JEP 430. And we, as I said, if we're lucky, we can see that maybe in Java 21, that would be kind of cool, but it's not settled at all whether that would be the case. And so let's go over this. So this is, as I said, this is a string template. First of all, I used the text block syntax here with the 3 quotation marks and then a new line, but that is unrelated. I only use that here because it's more readable, but you can totally do that with text blocks or with the more regular string literals. Okay, so what do we see here? First of all, what we see is that I actually do use this / curly brace syntax here, which is pretty handy because it's an illegal escape sequence at the moment. So there's no legal Java code out there that compiles and has a / curly brace in a string. So that's good. So that clearly demarcates this thing as something else. This is not a regular string. At the moment, what this is a templated string. I say in the moment because that's the current proposal that could evolve over the next months and maybe even years if it comes to that. Right, so what we have here, this part, the part after the 3 quotation marks, that is not a string, it's a templated string because it contains this stuff in here. It contains this reference to these 2 variables. And the second part is the template processor, str. And that template processor takes that templated string and turns it into a string in this case, into this query string. Okay, so these are these 2 ingredients. And the processor I just showed you, that was just this str processor just and concatenates the string. It does nothing fancy. It's just very simply whatever you say here will just be embedded here. So for example, what I'm doing here, apparently I have variables called desk, like description, price, quantity, tax. Those are all variables that are apparently being apparently defined before this piece of code, and they don't fit on the slides, so that's why I don't show you. What I'm doing here is I'm creating this block, which is like a payment slip, right? Something like a receipt that you would get when you buy something. And then I just concatenate this. And you can see here that I can do simple math here, for example. As I said, every kind of expression can go in here. But to keep it readable, that should probably be pretty short. And what it does is it just computes these expressions and then concatenates them as strings. And then it creates this payment slip, which is kind of nice. But it has like disadvantages. Because of this multiplication here with the tax, which is a decimal number, I get like this weird tax to pay. And I have to pay in total $27 and 18 cents and then 0.6 of a cent, which is really hard to pay in real life. So clearly what I want to do here is some rounding. And of course I could try to put that in here, but there is a system for that, right? Java has these format strings, and these format strings allow you to use this syntax. I always have to look it up. I think this one means 5 positions and 2 of them after the decimal point, and it's a number. I think that's what the %5(2f) means. I forgot the details. As I said, I always have to look it up. But the interesting thing here is that I use a different templating processor. Now I use FMTR instead of STR. And I use a different one because this different one follows different rules. It has a different task. STR just concatenates to a string. FMTR also interprets formatting strings, right? So it interprets these formatting thingies here, like the % to the F, and applies that to the number behind. And then that part disappears, right? The dollar is part of the output, but the rest here, that disappears, like in a formatting string, it would. And now I get rounding too. That's pretty nice. So now we have 2 template processors, STR and FMTR. Let's take a step back and discuss why we've been talking about strings. Because so far we said, look, we have as input a string and a bunch of variables, and we're going to put that together and get another string. Now, as I said earlier, we often want to produce these strings not for a human to read, but for another system, for another machine to read. So like, as I said, like the database or like the browser. And what we're basically doing is we're starting with a string and some values, and then we're creating the possibly simplest data format there is, which is just a string, which is just a char array, right? And then later, somebody else parses that to a SQL statement or maybe to a JSON object. And that begs the question, why do we go the detour? Why do we start with the string and the values separated, and then we make it all like the possibly dumbest data format we have, and then we try to interpret it? Couldn't we just go directly from string to the statement? And the answer is yes, we absolutely can. So we're not, we absolutely can if the enhancement proposal that we see at the moment will be implemented as is, right? So what I'm talking about now can, as I said, can change. Right, so the JEP proposes a template processor interface. And everything that implements an interface is a template processor. And this interface takes a templated string as input. That makes sense, right? Or rather the method in the interface. But what it returns is not a string necessarily. It's of type result. And result can be of any type. So a template processor takes in a templated string, but it can return any type it wants. So for example, it could return a statement. So this is the statement from the java.sql package, right? So it will be java.sql.statement class. And I have an instance query here that is created by creating this templated string and then passing it to this SQL template processor. And the interesting thing about that is that template processor could be on board with the JDK, but it doesn't have to be. It could also be provided by a library, which is actually not the worst thing, because then Java doesn't have to know all of these rules, format-specific rules for sanitization and for formatting. It can just, other libraries can provide that, right? You have a library maybe for JSON, you have another library for YAML, you have something else for SQL. And that makes it extensible by us, and then we can create our custom templating mechanisms, and they can return smart objects that we actually want to work with. And if, after all, we need it as a simple string, you can probably ask the statement to just give you the statement as a string. Same for JSON, for example, right? So let's say we want to create this little JSON document, and we want to embed name, phone, and address variables here to get the small little snippet. The totally fictitious JSON templating processor or template processor can return a JSON object. And then if I need to parse something, I can then already start with a JSON object, or I can turn that into a string really simply. So what custom templating allows us to do is to provide our own template processors that turn this templated string into a smart object that we then can work with. And that means that this processor can apply all format-specific rules. This processor can throw an exception if the SQL statement, for example, is not properly formatted. or rather, sorry, if the syntax isn't right. And also it can escape, right? So this SQL processor, it knows about SQL, so it can make sure that it escapes everything so that there will be no risk of injection attacks, for example. So this will improve the safety, but also the stability of these processes that build on creating strings for other systems, right? I'm really looking forward to that. Okay, but Amber does way more. Like, this slide is way too full, right? But I want to put everything on one slide because Amber is super, super busy. So as I said earlier, template strings, that JEP 430, you can look that up. That is currently not targeted to any Java release. As I said, I hope we could see that as a preview in 21, but we might not, right? That might still take a while. Maybe 2024 could even be longer. Theoretically, could even be axed, and we don't see that at all. But I really hope that's not happening to it. Other stuff that Amber does is a lot of that is concerned with pattern matching, right? So we have pattern matching in its 4th review in Java 20. So I really hope that eventually we're going to be done with that, and we're going to see it finalized, hopefully in 21. Record patterns are in its 2nd preview in Java 20, also something that could potentially be finalized this year. And then there are 2 very, very new JEP drafts that talk about primitive types and patterns, and about unnamed patterns and unnamed variables. I can't go into detail here because of we don't have that much time. But I want to also stress that these JEP drafts are still in a very early stage, right? So a lot of that is still going to change. It's just to give you an idea of what is being worked on. And so likewise, other stuff that will be that is currently being discussed or worked on is, for example, simplified main, a simpler launch protocol to make it easier specifically for new developers to start programming. A relaxed protocol for super. Even at the moment, when you want to call a constructor, and you implement a constructor, and the class that you're implementing this on has a super class, then you want to call the super constructor, and it has to happen on the first line, which is sometimes annoying. And so there are discussions. Maybe you can actually put code before super. That would be very interesting. There's the idea that we could have concise method bodies if a method just forwards to another method. Think of a wrapper around a list that just forwards everything to the wrapped list. There could be a way to make this kind of forwarding much simpler, so that it's more easy to recognize that it's forwarding and it takes less code. And there's conversation about revamping serialization, but that is surely long down the line. Like, the things at the bottom here, they're very speculative at the moment. Like, there's a good chance that we won't see all of them. We might not even see any of them. It depends on what happens over the next years. So overall, Project Ember works to make Java more expressive, to reduce the amount of code that we have to write, not because boilerplate is a problem, but because writing code is a problem, but because reading more code, having to jump through hoops to express something to our colleagues or to somebody who reviews the code, it's just uncomfortable, and it improves the situation in Java if Java can express common patterns more succinctly, and that will hopefully also make us more productive. Right, now, people often ask when that's going to happen, and these are my personal guesses. That's very important. Yes, I do work for Oracle, but if I would have an Oracle hat, I would now put it aside and put on my private hat and say, look, this is just my stuff, right? These are just my personal guesses for when these things can happen. So as I said earlier, pattern matching, and so the first part, JDK 20, that's not a guess. That's actually what's happening. Pattern matching and switches in the 4th preview, and record patterns are in the 2nd preview. But then I hope that for Java 21, we can see the template strings preview, and I hope that we see the first steps to a simplified launch protocol that makes it easier to, write a small snippet of Java code that just runs. And I guess in the next year, 2024, those steps are followed up on, that we get more towards the simplified main. And I also hope that the JEP drafts for primitive types and unnamed patterns, or primitive types in patterns, I should say, and unnamed patterns, that they also will show up in 2024. But that's, as I said, it's all speculation. What I'm showing you, what I want to communicate here is that all of these ideas and various stages of finalization. Some of them are already quite done, like pattern matching is in its 4th preview. Technically, it could still change radically, but that's very unlikely. Whereas stuff further down, that's further ahead in the future, has a higher chance of still changing. If you're interested to dive deeper in any of these topics, I leave you with a bunch of links here to other articles and videos that you can follow up on if you're interested. Okay, so this brings us to Panama. But before we go to Panama, are there any questions about Ember? Go to the top. So I have like a nice little view here. There we go. So I'll give you a minute or two.
Nikolai, hello. We have some questions. Let's ask them. So one question comes from Okan. He asks, can we pass method reference instead of static values?
Can we pass method references instead of static values? I don't quite understand. First of all, I don't understand pass to what, and then I'm not sure what a static value is. So I would need
probably for the string templates you mentioned about values. So instead of these values,
yes, I got it.
Can we pass just give methods instead of giving values like
good point? Yes,
text or other price, something like that.
So that's a very smart question. So here's the thing: if we think about this pattern, about this thing here. So the question is, here where I pass like just a fixed value. What else basically can I pass here? And you can pass everything that you want, but the processor that you pass this to has to understand it. So if you pass to str something here that is a string or number, that string or number will show up in the resulting string. If you call a method, then the return value of the method will turn up in the string. If you pass a method reference, well, it will basically call toString on this functional interface. And that would then probably not be what you expect. So if you assume that something should be executed here, then the template processor should know that it can receive in this templated string functional interfaces that it then needs to call a method on to execute them. So while that is possible, it's probably not the default, right? Because the most template processors will not be aware that they're supposed to call codes to execute code themselves. They're probably assuming that they're getting values. But nothing is stopping you from writing a processor that does that accepts lambdas and then assumes that that it has to execute them. That said, while I talked through this, I realized that as far as the Java language is concerned, I'm pretty sure that this will be an object. So you will pass objects. And if you want to pass a method reference, you first have to cast that method reference to a functional interface, because otherwise the compiler won't be happy, right? If you write object foo equals and then a method reference, that will not compile. So I guess putting a method reference here will also not compile. You have to cast it to some specific functional interface, which makes it not great.
Okay.
Right. By the way, I popped out the YouTube chat, and so I can see the questions myself, Everyone, if they're okay with that.
There is another, let me say, Oleg ask, or it's like a more, let me say, and comment when we can use new Java versions. As still there is Java 8 is used, but I know Java 11, Java 17 are used in productions. So here is the comment for you, Nikolai.
Yeah, right. So, what about this update process? I'm going to come back to that later, actually. I have a little bit on that later, and we can talk about it then. But it's a very pertinent question because I get that often, right? I usually talk about new stuff, and then there's always people in the audience who are like, I really want to use that, but nobody lets me write code in a new Java version. And I get that frustration. So we're going to talk about that later for a second.
I have one question, Nikolai, also, if it's okay for you.
Sure.
For the security perspective, so for the string templates, as you mentioned, so it's nice to have the code is more readable, other stuff, but so when I just check the expression, it may be open to SQL injections or something like that for this one. So how we can be sure about the security side also.
Right. So when you just put strings together, if you just concatenate strings, then pass that onto the database, the basic risk is that some of these variables here are not innocent variables. So we assume that value is just a little string, right? We assume that this is like, I don't know, a name or something, and like a name of a person. But if that person who provided that name is kind of evil, and he claims his name is something, and then a single quotation mark, and then a semicolon that ends that SQL command, and then a new SQL command, and I just embed that here and run that command, then that will be an issue, right? I'm executing other people's code in my database. I don't want that. That's the SQL injection tag. Now, there's largely two approaches to prevent that. One of them is to create a so-called prepared statement, which treats these things, whatever you pass on here, is not interpreted anymore. It's always just a string. It never becomes part of the syntax parsing. The prepared statement is parsed ahead of time, and then you only plug the value in. So with the prepared statement, you cannot have an SQL injection. I hope I get that right. Before you put that into production, ask your local security engineer. Don't come suing me.
Of course.
Yeah. And the other way is to escape something like backticks, right? Because not backticks, like the single quotation mark. If I escape that, then I would not have the situation that somebody can intentionally finish the select statement and start a new statement. And now the second approach, actually even the first maybe, is something that the SQL template processor can do. Because unlike when I just concatenate code ad hoc in my code that I write in my IDE, the SQL template processor actually knows that I'm supposed to do SQL here, and it can put in all the format-specific rules and all the escaping that I needed to do. So this processor here would probably get this templated string and would then make sure that these values are properly escaped. Or it might create a prepared statement first and then pass in these values. Although for that, it probably needs a database connection. So that might not be what it can actually do in practice. But what I'm saying is this system knows about SQL, and it doesn't do it automatically, but it can be written in such a way that it will make sure that this template process, that this SQL string is properly escaped, and so I don't have the security advantage. And the reason why it returns something smarter than a string, by the way, is because it already goes through the work effectively of parsing this, right? If my SQL, a template processor, is supposed to escape everything properly, it might as well parse this while it's at it. And then once it has parsed everything, it might as well return it as an SQL statement instead of then dumbing it back down to a simple string.
Thank you. Nikolai, also, let me ask one general question. It's not just about Amber, by the way. Is there a way for contribution to these GEPs, JDK enhancement proposals for everyone, or just it is developed in, let me say, Oracle side? It will be good for the open sourcers, let me say. Right.
So Java and its implementation, specifically the JDK, is developed in OpenJDK. OpenJDK is a community, and it's a community that is primarily a community of individuals. So while there are some very sparse places where in the bylaws, which are the laws that govern OpenJDK, companies are mentioned, that's just that, and those are important positions, don't get me wrong. In the day-to-day business, what matters are the people that work in this project. Now, of course, the people work there full-time and they are getting paid for it. So, of course, companies have some influence, right? Of course, like Oracle pays most of the work that happens there, and Red Hat pays a bunch of people, and IBM, and there's so many companies, Microsoft, that are contributing to this. But within the confines of OpenJDK, those companies really step into the background. What you have in OpenJDK is a community of people working together to create the reference implementation for Java. And they do that out in the open. And the main mechanism by which they do that is the code is on GitHub. So there is, if you go to github.com/openjdk/jdk, you will find the very Java mainline code that will eventually be built, and you will run it on your system or on your servers. So that's the one part. The code is open source, and each of these projects, like Amber, like Valhalla, has their own forks. Amber probably has a bunch of them because it does all these different things. But there's one fork for Loom in the past. There's one fork for Valhalla still out there that contains all the code that is being worked on in Valhalla. And eventually, all of those projects, if they succeed and reach their goal, merge their changes back into OpenJDK/JDK, the mainline. And the second way that this is developed out in the open is the OpenJDK mailing list. Or mailing lists, I should say. There's a ton of them. So if people want to contribute, I recommend them to go to dev.java. That's the website that we at the Java team at Oracle have created. And you will find at the top a way in the navigation to go to a page that tells you how to contribute. because contributing code, particularly to new language features, is probably the last step of many, many steps that you can take to contribute. It's by far the hardest and the slowest and probably the most frustrating part to contribute to OpenJDK, just because these things are so important that you will be dealing with people who work on this full time for years now, and being like, well, I have time every Thursday afternoon for a couple hours is probably not going to cut it. So what I recommend if you want to contribute is go to dev.java and read through that and start way smaller. Go to the OpenJDK mailing lists, follow what is happening, come to talks like this and just follow what's happening. And then the simplest way to contribute, even though it does not seem, may not seem like contribution, is to try these things out in practice, right? So for example, when you hear about data-oriented programming, get the actually all the parts that you need for that are currently already in the JDK in the main line. You need to activate some preview features. Do that. Create a demo project, or maybe even take your actual code base and take a couple of days and try to apply these new concepts, try to apply new features, try to apply virtual threads from Loom. If you're interested in native programming, try to use JExtract or the foreign memory API that come from Project Panama, and try to use something that deals with native code. Take these things that are currently in development, try them out as much as you can, like meaning not just like in play projects. Ideally, if you can, try them out in production code. Don't put it into production, but take actual use cases with all the all the ugly little sides that they have, all the extra requirements that make it different from a demo project that I can fit on my slide, and then report back. That's the best way to contribute, because all of this is done out in the open, but that doesn't do much if the community does not experiment with this and give feedback. And the community does do that, but more is always better. Run against early access builds. Right now, for example, you can run against Java 21, JDK 21 early access builds already. Have your build pipeline set up so it builds against that. Ideally, also run your performance tests on that. And then take those results back to the OpenJDK mailing lists and tell the people, look, I've worked with data-oriented programming. That was great. Or I found a performance regression that has to do with generational ZGC. Or I applied template strings and this and that didn't work out. That's the best way to contribute. And from there, there's kind of like a natural path of staying involved in the conversation online, and then maybe start picking up smaller issues that revolve around that. And I think from there, there's a path to more serious, these contributions are also serious, I should really say that. But I mean, like, to more, the kind of contributions that we always have in mind, like new APIs or new language features. But that's really a very lofty goal that happens usually after like years and years of contributions. And also usually most people who do that kind of contribution on that level often are paid for that specifically by some company, because it's something that's really hard to do in your free time, just because it requires so much time.
Thank you, Nikolai, for the detailed explanation. Yeah. I think we can go to the next one.
Yeah, and since we're here, actually, I want to talk about that in the beginning, but I forgot. What even is a project? Why am I talking about projects? But since we already talked about OpenJDK, let me quickly explain that as well. As I said, OpenJDK is an open community that works on these on Java. And whenever people in the community realize that there's a shortcoming that Java has that needs to be addressed, what they can do is they can sit down, they can talk it through, and they can realize, okay, we want to create a project that tackles this issue. And then there's a process. You cannot just start a project and do stuff. You have to there's a process within OpenJDK. You have to find people who agree that this is a problem and then back you on that. But largely speaking, what you will do is you will create a project like Project Panama, for example, and then under that project you will work a lot on that problem, often creating prototypes, experimenting with them, presumably failing. Probably Valhalla has been in work for like 10 years. Mostly just stuck in this prototype loop because it's a complicated project that requires a lot of learning. And then eventually, when you come to when these plans that you have come to fruition and you're about to propose actual changes, those would be JEPs, JDK enhancement proposals. So projects are basically the container in which changes are being experimented with and worked out, and eventually at the end of that process they are proposed as JEPs. And from there, they may make it into the project, into the main code. And as I mentioned, most of these projects will then be done. They have a bunch of proposals, 1, 5, 20, I don't know. And when they are merged, they're all done. Okay, so what is Project Panama about? Project Panama is about interconnecting JVM and native code. Again, there are a bunch of links here that you can follow up in if you're interested in the project. And it largely falls apart into 3 sub-projects: the vector API, the foreign memory API, and the foreign function API. And the last 2 are often grouped together as foreign APIs because they deal with 2 different aspects that can often work together. I will show you in a minute. Let's start with vector API. Let's start with vectorization. What I have here is a very simple loop that goes through 2 arrays, array A and array B, and creates a result array C, or rather it fills up a results array C by doing this computation. It squares A, it squares B, it adds them up and takes the negative and puts them into C. So all of these arrays have to have the same length. So it takes 1 number from A, 1 from B, and creates a result in C. Simple, right? It goes from 0 to length, and then just does the math here, and then puts it into C. Good, straightforward. But if we do it like this, we're missing out on something. What we're missing out on is vectorization, or rather, the vector capabilities of modern CPUs. So modern CPUs have what's called multi-word registers. My laptop has 512-bit. My old Ryzen CPU had 256. This one is a new CPU. I don't actually know how wide these registers are. But let's say you have a 512-bit multi-word register. You can store 16 floats in that thing. And the cool thing is that your modern CPU can take 2 of these multi-word registers and add them, for example, or multiply, or do a number of other operations, basically in a single CPU cycle. So instead of taking 2 floats and creating 1 result, you can take 2 times 16 floats and create 16 results in the same amount of time. And that's big, right? That would be a huge speed up. This is also called SIMD, single instruction multiple data, because you have this, as I said, let's say 16 pairs of floats, and so that's the multiple data, and the single instruction will be add or multiply or whatever. And this is, I think, like the first time, or rather, the first thing that I remember that in retrospect does this is, I think, the MMX extension. If you remember, like in the middle 90s, the Intel MMX processors, that was what this was about. That is multimedia extension. That was surely among other things, but that was these vector capabilities. Because when you deal with media, for example, with image manipulation or video decoding or encoding, you want to do a lot of math, and you want to do all of that math on a lot of data. So you're basically saying, look, I have like a mathematical operation that I need to execute on this huge image, which is like, I don't know, a couple million bytes. And you want to do always the same operation on a lot of data. And that's where these extensions come in handy. Now, the just-in-time compiler knows about that. It knows that this is a concept in CPUs, and the just-in-time compiler knows which exact CPU it's running on, right? And so it tries to do that. It tries to figure out, wait, this loop, that looks like something that could benefit from these vector APIs. From this vector extension in the CPU. And it tries to create that machine code. Now, I should say it tries, because it can only do that when it can prove that using those instructions instead of the instruction that you actually coded is still correct. It has to guarantee that it's correct, of course. And it can do that. It cannot do that reliably. It's very easy for you to write code that auto-vectorizes and then make a small change. And due to that small change, the just-in-time compiler can no longer prove that it can create equivalent code, and then it doesn't do the optimization. So this is a nice performance benefit to get, but it's unreliable. You cannot rely on that benefit to be there all the time. And this is where the vector API comes in. The vector API makes the same operation slightly more complicated, but it has a big advantage that I'm going to come to in a second. I'm not going to go over all this code in detail. We don't need to. What's important is that I still have these 3 arrays as input, A, B, C, which A and B as the values and then C as the results. But what I do now is I don't step in the length of 1. I step in the length of this vector species, whatever that is. But for the example I just gave, if we're dealing with floats on my laptop, the length would be 16. So it goes in steps of 16 over this array, and then it takes from array a vector A, from array B, a vector B, and then it does math with method calls, something everybody loves from big decimal. So we go A times A and B times B, and then we add it up and negate it, and then we write the result into C. So this is the same computation, slightly more complicated. What do I get for that? So the cool part about this is that this will reliably create vector instructions. This API is written in a way that it mirrors, or at least resembles, the specific vector CPU instructions that I found across many different CPUs. So you can use this API in Java, so it's platform agnostic, and it's given the requirements pretty clear and concise, actually. Sometimes a little bit of a twist, of a mental twist, to understand how to create an algorithm in that API, but that's actually quite an interesting challenge. And what you will then get by the just-in-time compiler is optimal code for the CPU it's running on. It will always hit the CPU instructions if they exist. Even if they don't, if you run on a very limited hardware, very old hardware, you will still get graceful degradation. The end result will then not be worse than the regular loop. So like it can never be worse than the loop, like the regular for loop that you would write. But it can be, and will be better on suitable CPUs, which nowadays are basically all the CPUs that are out there. And that's just great. Like if you do something like image manipulation, as I said, video decoding or encoding, or for example, machine learning, which is also very math heavy, everything that does a lot of computations with numbers, all of that work great with the vector API. And while it's not very likely that you will start using it, it is very likely that your dependencies will start using it, right? Because most of us, if we deal with images, don't actually do that ourselves. We call a library for that. But those libraries, once this API is out and finalized, will surely jump on it, and it will give us all a nice performance boost. Okay, now let's talk about foreign memory API. That's the second of the three topics, right? Vector API was first. Let's talk about foreign memory API. At the moment, when you want to store stuff off heap, you either use the byte buffer, which is only 2 GB large maximum, and it's somewhat inefficient, or you use unsafe, which is unsafe and not supported. So that's not a great idea. But you basically, you have this tension between the right solution, which is, as I said, limited and inefficient, and the dangerous solution, which might give you the characteristics you want, except that it's unmaintained and can stop working anytime, which is not great. So Project Panama introduces a safe and performant API to deal with memory that is off heap. I will come in a second to why you won't want that, by the way, if you're not sure. The interesting thing that it does, that unlike byte buffer, which is just a single class, it's much more detailed API that allows you to have more influence over what's happening, which is important because this is not a simple problem. So to allocate, it gives you memory segment and segment allocator classes, gives you memory layout and var handler classes to access and manipulate that memory, and you have arena and segment scope to control the allocation and deallocation of that memory. So what would I want to do here? So I have an example here where I want to allocate some off-heap memory to store some pointers, and then I want to do something with off-heap data. What I often want to do with that is call a native method. Maybe I'm doing machine learning, and machine learning library that I'm using is written in C. So what I need to do is I need to execute C code, but before I can execute it, I need to give it some data, right? So first I need to give it data, but I cannot give it data that is on heap because the garbage collector has control over what's happening on heap, and it might shuffle data around. And it's not really great to give your C library pointers into the heap, and then it starts reading and writing there while the garbage collector is pushing stuff around. That's not recommended, to say the least. So you need to put stuff off heap where the garbage collector cannot reach it, and then call the native library on native code on that. And once you're done, you want to copy the data back onto the heap and continue processing. And the way that the for memory API does that is by giving you the so-called arena, with which you manage the lifetime of off-heap memory. So we start here, we open an arena here in this try with resources block, and at the end of the try with resources block, the off-heap memory is automatically deallocated, which is great because it's also an issue with byte buffer that you don't have a lot of control over when the memory gets deallocated. Good. Now I have 3 steps in here: the allocation, the doing something with it, and getting data back. Let's start with the allocation. So I have this string array here, which consists of these, mouse, cat, and dog. I have the arena as before, as I mentioned. And what I can do now is I can allocate an array. Once again, I'm not going to go into too much detail, but I can allocate an array, and then I iterate over my Java array and turn that into a native string, and then put that into the native memory, the off-heap memory, right? So this API, once again, like before with the vector API, of course, is more complicated than just simple Java code. But the reason for that is that I'm doing something that needs to be, in this case, safe. It needs to be ideally still type safe, but it still deals with something that is inherently unlike Java, because the off-heap memory is not actually it's not managed by the garbage collector, and it's not necessarily we don't know which types are there on actually. Okay, so this is the way to shuffle something off heap with, like, as I said, memory segment class. And then I can do something with it. We're going to come to that in a second. And then I want to have it back. And when I get it back, it's simple. It's very similar to before. I once again iterate. And from this memory segment that I have, from these pointers that I have, I get a specific index. And from that memory segment, I can then say, okay, give me a UTF-8 string. So this part is funny, right? Because, well, it could be a number, right? Somebody, the code that I called might have placed a number there, and I need to know that here. That's why I said, like, because what happens natively, I have no control over the types. It's just, bytes essentially. So when I read it back, I need to know what it is. This case, I say it is a UTF-8 string that I'm expecting there, but it could, maybe it's, as I said, it could be a number or something, right? So I have to know here what the native code creates so I can read it in. And that's the way to shuffle stuff in off heap and then get it back. And in between, I often want to call a native library. As I said, I gave machine learning as an example. It might also be a library that interacts, for example, with the operating system I'm working on. Maybe I'm creating something for Linux that's specific to, maybe, I'm not sure whether that actually works, but you can imagine creating a Linux native UI, not Swing, not JavaFX, but something native by communicating with the C library or the C++ library that does that. Probably not a good idea though, but there are other reasons, right, where you have local native libraries that you want to interact with. And the current way to do that is JNI, the Java Native Interface, but that is not ideal. It has a bunch, it's a very complicated process that's very fragile. It's easy to make mistakes and things fall apart and can be complicated to put back together. And also doesn't reconcile the Java and C type system. It creates, much of that process is specific to an operating system or architecture. So it works, but it's not great. And by the way, one of the reasons why in machine learning, Java does not play a big role at the moment is this, right? So what language plays a big role in machine learning? It's Python. There are different reasons for that, but surely one reason for that is that Python makes it much more comfortable to work with native code, which means it's easier to get started. And if you already started and already added a couple months of work, then you will obviously keep going. Even if maybe in the long run, Java would have been the better choice. Once you invested a year into a project on one language, you're probably going to stay there. So that JNI is so fragile and complicated is one of the reasons why Java is not strong in the machine learning field, because performance matters so much. Most of the, or actually I think all of the important libraries are written in C. And Python makes it easy to interact with C, and the JNI, not so easy. And the foreign function APIs want to improve that. So the Panama introduces a streamlined tooling and API, both of that, that work based on method handles, which was something introduced in Java 7, I want to say, or maybe 8, or 9 even. I'm not sure. It's it is an API that you can use, but it's mostly something that will be used by people creating, or working with reflection and reflective code and that kind of stuff. So it's not something that you and I are probably going to use day in, day out. Okay, a very important part of the foreign function API is JExtract. So JExtract is a tool, a command line tool that you can send to a header file, for example, and will then generate low-level Java code that mirrors the API one-to-one. So it uses method handles to call into the native code, which is safer and, type safer and also more performant than what JNI can offer. And also it does it automatically. And then what you would do is you would build your own API on top of that Java file. So you have an automatic process from header file to Java file, and then you build that, and that API is basically one-to-one. And then you can create your API on top of the Java file. And when the native library gets an update, you rerun JExtract, and then you will get where it suits compile errors, maybe because maybe some of the methods change their signature, and then you can update your Java code accordingly. So the idea is to use JExtract to generate an API and then build your own on top of that. And this is, for example, how I would call Radix sort in a Java standard, in a C standard library. So I start with the linker. I fetch the native linker. I fetch the default lookup, and then I look in that standard library. I look for Radix sort, just a sort implementation. So what I'm getting here is a method handle to the native function Radix sort. Now I again have my array of Java strings here. Then I move the stuff off heap as I showed earlier, right? So then I now have it in this off heap memory. And now I invoke on this off heap memory, I invoke radix sort by passing a bunch of parameters. And then radix, that's the native part, right? Then the native C library runs, does its thing. When it's done, this call returns, and then I can copy the data back to the heap. So there's a part of a sentence missing here. So Project Panama connects Java with native code. That's seriously broken, that slide. And it allows to do a reliable, safe, and also slightly faster interaction with foreign memory and foreign function. And it's important to also fold in the vector API, because that's also something where it's about being closer to the metal, basically. Getting, in specific cases where I need that, writing code that is not quite as high level as I'm used to from Java, and in exchange getting a good performance. Now, this timeline is not my guesswork. It is the official timeline, which is that in JDK 20, the foreign APIs do their second preview. And then hopefully, maybe, I'm not sure about that though, in Java 21, the foreign APIs might actually finalize. We'll see. Nobody knows. The interesting part is that the vector API will still take a while longer. We still have to wait for that. In fact, in JDK 20, we didn't see any changes to the vector API. It still stays incubating for now, which means you can write code against it if you pass the command line flags, but it could technically still change. And that means that you should probably not bet a lot of production code on that, if production code at all. The reason for that is that the vector API will be improved in parts. So some parts of vector API, I mean, will be greatly improved once Valhalla's primitive types and universal generics roll around. If you're not sure what that is, don't worry, we'll come to that next. But that's, and then since that will change the API, nobody's really keen on finalizing it now, and then in a year or two regret it, because now you have a different tool that would make the API nicer to use. So that's why the vector API hovers in this incubating state, that even though it is pretty good, it's really refined. I actually don't expect anything to change except for maybe some small parts, and then the parts that are already known to interact with primitive types and universal generics. But I think probably the shape of the API and everything that is unrelated to Valhalla will stay as is. That's my personal guess, at least. For deeper dives into the vector API, I can recommend the JEP itself. And then there's a great article by Gunnar Morling, who implemented FizzBuzz, the famous interview question, Cindy style, meaning with the vector API. And I find that post interesting because clearly the vector API is not meant for that kind of stuff. So he has to jump through a few hoops and has to figure out a few things to get to that implementation, which is a great way to learn the API. If you're interested in the foreign APIs, there's a bunch of stuff here that I've linked, specifically the state of documents. Whenever you find a state of foreign memory or state of Project Valhalla or state of whatever Amber of these documents, they're usually written by the project lead of these projects. There's often a lot of work going in there and really states where the project is right now, what the problem is, what the considered solutions were, what the current solution is that's being proposed, whatever is being worked on. And that's just a great way to learn more about the specific project, what it's doing, but often also shares a lot of information about the background, about why the existing situation is as it is. So it's a great way to learn about Java in general, and they're often written in a very approachable way. So I found that up until the nitty-gritty technical details come up, which I sometimes also don't get. So for example, when I talk about Valhalla and changes in the JVM, I'm lost. Foreign memory, native code is not at all my thing. I don't even know C, so I get lost here as well. But up until the part that you get lost, they often it's the first half where they explain what the problem is and what the proposed solution roughly looks like, and that's always very, very informative. I can only recommend to read these articles whenever you have a chance. Do we have questions about Panama?
Nikolai, I don't see any question, but I have two, by the way. But you answered one of them. So one of is about foreign APIs. So foreign API will going to replace GNI, right? The native interface totally when it is live with.
Right. So it will replace
Java 2.1.
It will provide an additional way to do that, a better way to do that. But GNI will, of course, still be around, right? It's not going to get removed. But yes, it will give you a better way to do that thing. Yes. I'm not sure. I expect it to cover 100% of what GNI can do. but I cannot guarantee that. Maybe there are some things that you can do with JNI that Panama is not touching on, but I don't think so actually. But I don't know. As I said, like C is not my forte, so I can actually say that for sure.
So the other question would be about the interaction between garbage collector and the memory API, but you answered it during the question.
Right.
So
yeah, but since you asked us, we can still go into that a little bit. So the interesting thing is that the garbage collector is not concerned with off-heap memory, right? So if you say I need like 2 gigabytes off-heap, that's between you and the operating system mostly, right? So there's not like a lot that the garbage collector can do. But the issue is that the JVM does track whether you still reference that memory, because like you can free memory. There's no way with byte buffer to say explicitly, now I want to free this. You reserve memory with the byte buffer, and then what you do is you rely on the garbage collector collecting the byte buffer instance once it is no longer in scope, and then the memory can be freed. The issue with that is that from the perspective of the garbage collector, the byte buffer instance is very small because the byte buffer is not 2 gigabytes. The byte buffer only references 2 gigabyte of off-heap memory. So that means that the byte buffer can sit in some region of the garbage collector that is not on a very high priority for being compacted. So that might sit around for a while if your app does not have a lot of pressure on the garbage collection. So objects that go out of scope might sit as garbage for a while because usually it doesn't hurt. But in this case, it hurts because your like little byte buffer that sits somewhere still references 2 gigabytes of off-heap memory, and they will not get freed until the byte buffer is collected. And that's actually an issue, that the byte buffer cannot be collected explicitly. And that's something that the foreign memory API specifically tackles. How do you deallocate memory? How can you make sure that the memory can be freed when you are done with that section, or with the block of code that uses the memory? And beyond that, concurrency becomes an interesting issue. So if you have this in a multi-threaded situation, when are all the threads done? That's actually not easy to figure out, and it's dangerous, because what you do not want to do is you not want to start freeing the memory while another thread still thinks it can use it, and then the memory is like freed, but one thread still writes to it. So that's a little bit of an issue. And the interesting thing is that the proper solution that is thread safe is a performance drag to a point, right? It requires more coordination between threads, and it hinders performance, which is okay if you actually do use multiple threads. But what if you don't? What if you just use one thread? It would be sad if every user who uses off-heap memory in the new API would have to pay that price for thread-safe deallocation if most of your use cases might not even use several threads. So that's one example where the foreign memory APIs give you more freedom, because you can actually decide that. You can actually make sure that you only get, in this case, you only pay the price for thread-safe deallocation if you actually need it. So that's an example of why the foreign memory API is more complicated than byte buffer, because it allows you more interaction with it. It does not try to take a complicated problem and give you a simple API for it. It knows it's a complicated problem, so the API can be a little bit. It doesn't have to be the simplest possible. Well, it needs to be the simplest possible API without being too simple. And that's something that, for example, we've seen in the past with the datetime API, right? Before Java 8's datetime API, we had calendar and date. And that was really bad, like for very many reasons. But one of the reasons was that they tried to take a very complex problem, which is times and time zones and dates, and force them into two somewhat simple-ish classes. And that did not work out. So look at the datetime API, heavily inspired by JodaTime. That does not have just like a date object. It has, local datetime and zone datetime and zone, like it has so many different classes, because it reflects many different possible situations. And a little bit like that is what's happening here as well, where Panama is not trying to map a complex problem onto a very simple API. Instead, it's trying to map a complex problem on an API that can actually deal with that complexity. So it gives you more control over many aspects of the foreign memory. Okay.
Thank you, Nikolai, for the explanation. Yeah. Thank you.
I forgot to talk about this slide.
We can go forward.
Yeah, so Project Valhalla has a very weird claim. It says it deals with advanced Java VM and language feature candidates, which is very like that could be everything. It's very vague. We're going to see in a second what it actually does. Once again, I have linked to the project, the wiki, the mailing list, but Valhalla also has a recently updated early access build. So if what I show you here seems interesting to you, and I guess it will be to many of you actually, go check out the early access build. You can download a full JDK that contains many of the features that I'm going to walk you through, and you can already experiment with them. As I said, this was launched in July 2014, so 8.5 years ago. It's led by Brian Getz and John Rose, and is of the projects that I show you here, definitely the most, how would I say, the most courageous one, the one that requires the deepest changes to how Java is today. Because it deals with a very, very basic thing in Java, namely its type system. Java's type system is split between primitives and classes, which are different in basically every aspect in which you can say types could be different. One of them can be null, the other can't. One of them is safe from tearing, the other isn't. One of them we can create, the others we can't. One of them can implement interfaces, the others can't. Like there's a huge disparity in basically every way that you can distinguish different kind of types. These are different. And the issue is with that, so that's already an issue, that there's this big gulf between these two types. But another issue is that we can only create classes. And classes always have identity and always are references. What do I mean by that? Well, technically the classes are not references, but the objects that you instantiate, but allow me that for succinctness. So all classes come with identity. That means that the JVM tracks individual instances to distinguish two instances of otherwise what could be the same thing. So let me give you an example. If you write int 5, int f equals 5, and then you write int bar equals 5. So f and bar, foo and bar. So you have foo and bar. Both of them are 5. Are they the same or are they different? The question doesn't even really make sense. Like, it's hard to compute. They're both 5. How can they not be the same? What would that even mean? Okay, so clearly, those things, when they have the same value, they're the same thing. Now, let's say I write integer foo is new integer 5, and integer bar is new integer 5. They have this. They're equal in the sense that they have the equal value, right? But are they the same? No, they're not the same. One of them is foo and one of them is bar. And for example, if I create a lock on one of them, if I use a synchronized lock on one of them, I don't have a synchronized lock on the other. There's two instances that are equal, but they're somehow not the same. And that's what identity is. Identity means that things that are equal can still be not the same thing. And that is, in many ways, pretty good. Like, it's not like we don't need that. The question is, do we always need it? Because identity comes with a price. It requires extra memory for the header. It's required for mutability, which means if you want reliable immutability, enforced immutability, identity is actually a little bit of a downside. It allows the locking with synchronization, all of that. And not all custom types need that. That's the basic point. None of these things are bad, but not all types need that, but all types pay for it. I mean, all types that we create. And then classes also are, or instances of a class also are references. That's the memory access indirection. So for example, if you have a list of integer, what you have is probably an array list that uses an object array, and that object array then every object points to some other position in the memory where the actual int, the backing int, is lying, right? That's the typical Java reference and the resulting indirection that you get, which usually is not a problem. But there are definitely situations where it becomes a problem. Where, just as I said earlier, just as I said right now, if you have this array of integer and you iterate over that array, the whole machinery in the CPU is basically laid out with the idea: look, if you have a predictable pattern like that, I know what kind of memory you're accessing, and I can make sure that it's very available, right? You have these cache lines and everything. You go through an array. The memory system fetches the entire part of the array. If you go through it, everything will be in cache. Everything will be super fast. Except that everything that you fetch is not actually a number. Everything that you fetch is an address to a number. So then you go probably off the memory page, get a cache miss, and all of that drags performance down. That's why people who deal with high-performance Java, for example, maybe for games where you want to avoid garbage collection too, by the way, but also where you want to do like computations based on coordinates, right? Imagine you're creating a game which is like a two-dimensional game, has x and y coordinates, which is A great coordinate class, you have a coordinate that has like an X and a Y entry. But an array of those things is not an array of X, Y, X, Y. No, it's an array of pointers. And then grabbing all of those is a memory direction that costs you dearly in a situation where performance is important. So you would maybe create two arrays, one of them containing the X and one of them containing the Y coordinates. That kind of works, but it's not the code that you wanted to write. It's the code that you have to write because of performance. And that's not great. So this memory access indirection is perfectly fine with many, many objects, but some that we want to create would really suffer from that. And so we sometimes have to avoid creating the classes and objects that we want to. Also, if you have references, you can have null, which I personally hate with a passion, so that's not great. You get protection from tearing, which I'm not going to go into today. And again, not all custom types need that. So Project Valhalla steps up and says, look, we're going to unify the type system by giving you options in between. You have primitives, which have neither identity nor other references. You have classes which are both. Now let's fill the in-between. Let's have value types, which do not have identity. Let's have primitive types, which have neither identity nor references, and thus fill out the space in between these two poles. And then there's two more proposals, or things that hopefully will be proposed in the future, which is universal generics, which allow you to write something like array list of int, which allow you to write use primitives in generics. Don't get too excited yet, because this would only be a syntax change. That change would actually is probably comparatively easy, because this would still get boxed. You would still have an object array in the back, which is not great. What you want to have is an int array, right? You want to be backed by an int array. And that's called specialized generics. So universal generics means the language now accepts all kinds of types in generics, not only classes, also primitives and also the value types and primitive types that we create. And specialized generics means at runtime, the bytecode that gets executed, or rather the machine code that is generated later, will actually use that potentially primitive type as an array instead of wrapping it into an object. Okay, let's go over this a little bit. Let's start with the value types. What I have here is a rational number, so that has a nominator and a denominator. It's a regular class, but it uses this new situative keyword value here. And what that does is it turns this into a value type, right? So what I said earlier, I'm going to go over that in a minute. That applies here. And this code's almost like a class. Like you can do all the class things, right? You can write methods, you can implement interfaces, you can do all the good stuff, except the class and its fields are implicitly final, and the superclasses are very limited. It's almost as if you can have no superclasses at all, but that's not entirely true. There's a very limited kind of superclass that you can have. But roughly speaking, imagine that this has no inheritance and the fields are final. Other than that, do whatever you want. Now, these types don't have identity. That means, for example, you cannot lock on them. You cannot have like a synchronized block on them. If you do, you get an exception. And you can also not check the identity with the two equal signs, right? Because they don't have identity. So how can you check whether the one integer 5 is the same as the other integer 5? You can't, because they don't have identity. So instead, this reverts back to basically an equals. It compares not the identity of the elements because they don't have one. Instead, it compares them by state. What you get from that is guaranteed immutability. As I said, everything is final. You can better express a value. Think about domain-driven design, where the concept of a value actually exists, and it's nice that you can now express that easily. But when it comes to performance, definitely the most important part is that the JVM does not have to track identity and can thus improve the performance of these kinds of types. But there's the references. You still have null as a default value, and you still have the guarantee that there will be no tearing. The JDK, as well as other libraries, has many value-based classes, such as optional and local datetime. We plan to migrate many value-based classes in the JDK to value classes. So the proposal is, once we get value classes, stuff like optional, local datetime, and other stuff that really wants to be a value class or value type can then be one. It will become one. Now you might think, wait a moment, isn't that like a backwards incompatible change? I just said that some runtime operations throw exceptions. So that means something I can do with optional now will not be possible anymore with optional in the future? That is true. But technically, it's not a backwards incompatible change because optional was introduced in Java 8, just like local datetime. And when it says value-based class here, that is not just a phrase. that is a specific term that Java 8 introduced. So in Java 8, these types that were added, they have a line usually at the end of the Java doc that says, this class is a value-based class, not all operations are allowed, something like that. And if you click value-based is a link, if you click on that, you come to another Java doc page that introduces the concept of a value-based class and describes the limitations. Because the fun fact is that Ryan gets, as soon as 2014, or could already had an idea of what these limitations would be. And so they put these limitations in the Java doc. So yes, if you lock on an optional, you will get an exception, most likely in some future version of Java. But you already should not be doing that. The optional Java doc clearly states, don't do this. So locking an optional is kind of fishy anyway. But yeah, maybe, if you deal with these value-based classes from Java 8, that I think most of them were introduced in Java 8, but there, could be others from later. Keep that in mind. Maybe have an eye open for these identity-sensitive operations, and do read up on what a value-based class is. I wrote a blog post about that 8 years ago, when Java 8 was fairly new. So just Google for value-based classes, whatever blog post you find. I hope it's mine, but if it's another one, it's probably going to help you too. Read up on that. Make sure that you don't do these things that you're not supposed to. Okay, let's keep going. Primitive types. This primitive type looks very much like the value type that I created earlier, but this time I'm dealing with a complex number, has a rational and irrational part, and this codes almost like a value class. So the limitation from the value class apply. There's one more limitation. You cannot have a field of your own type. You cannot have cycles there. And there are different reasons for that. One of the reasons is that a primitive class cannot be null. So a primitive class has no identity, just like value types. So everything I said there applies, but also it doesn't have references. So that means there exists a default value. That default value has all fields set to their defaults. So this one would have 0, 0 as a default. But if you have a field of your own type and it cannot be null, then what would be the instance? And then you come into that would be an infinite progression, right? So it would be very weird. So that's one reason why it's not allowed. Okay. Why did I make the irrational type a primitive class, but the nominator-denominator a value class, the rational number? The reason for that is that the default value of a primitive class has all fields set to their default. So for numbers, that's 0, 0. And a complex number that has rational and irrational part 0, that's a meaningful number. That's just the complex number 0. It's a good default. It's like the 0 from integer. Perfect. Works like a charm. Now let's go back here. If this were a primitive class, I could not set it to null. Its default value would be 0, 0. Now if the denominator is 0, or the nominator? Well, the thing at the bottom, right? If that is 0, then this is an ill-defined rational number. It is not a number. You have as a default value an illegal number, and as soon as you do any kind of math with that, everything explodes, right? You immediately get like something plus this is not a number. Something times this is not a number. That's not a good place to be in, right? To have a default value that breaks every kind of operation is not good. So that's why the 0, 0 would be really bad default value for rational number. I need another default value. And that default value is null. As much as it pains me to say that, null is the best default value here. So because I need it to be null, or I need it to be able to be null, I need it to be a reference. And that means I need to make it a value class. I cannot make it a primitive class. That will be the distinction. Whenever I think about value versus primitive, the question is, do I need references? What do they get me? They get me null as a default value, and they get me protection from tearing. If I need one of those two things, I get a value class. If I don't, I get a primitive class. Okay, the benefit that I get here is that the performance after just-in-time compilation is comparable to that of today's primitives. Let that sink in. You will be able to create something like complex number that has basically the same performance as integer does today, which is huge, right? We can talk about boxes, but in the interest of time, I want to skip this part. Just suffice it to say that just like there is integer for int, there will be something for the primitive types like complex number that you can use to create a box that can then be null after all. Okay, let's go to universal generics. Now, in the past, we had primitives which do not work with, or actually in the present, we have primitives that don't work with generics, and we have our own classes that do. And like, it's a thorn in our side that you cannot generify over primitive types. But it's not that bad. Sorry, or primitives, I should say. But it's not that bad, because primitives are not domain objects, right? Array list of int, yes, sometimes it would be handy, but often we want to have an array list of something meaningful, something, a type that plays a role in our system. So, not being able to do that is not, as I said, it's a thorn, but it's not horrible. But now imagine everybody creating their own value types and primitive types, and they would also all be excluded from generics. That would be horrible, because that means we have this entire new language feature that as soon as it gets in touch with another very essential language feature, namely generics, it immediately falls apart. That is not a good situation. So project Valhalla needs to overcome this. It needs to allow, and universal generics do that, it needs to allow us to use all kinds of classes as type parameters. That's true for or that will hopefully be true for the very primitives that Java came with, but also for all the primitive types and value types that we create ourselves. It will be possible, hopefully, to use that in generics. And that's huge, right? That's very, very cool. I'm really looking forward to that. But keep in mind what I said earlier, this would still be backed by object arrays, right? So this array list would not have a long array, it would have an object array, which is not great. So now let's get to that case. To completely heal the rift between all of that, not just in the language, but also at runtime, we need to make sure that the array list of int is no longer backed by an object array. Because if it is that, then yes, it's nice that I can now express that in the language. It's better than before, but it would also lead to issues where people hope for or assume they will have a certain performance characteristic that they then won't get. We developers are prone to eagerly optimize, or to prematurely optimize probably, and that could lead us once again away from creating the design that we want in favor of the performance that we need, or that we at least think we need. And specialized generics will fix that by allowing us not only generics or primitives, but that they will actually avoid references. We'll be finally in a situation where we can create the design that we want with the performance that we need. And even if we don't need that performance, it's still pretty cool to be given for free, right? It's not only about performance to use primitive and value types. As I said, you get immutability, you get null safety. If you have something like a complex number, you don't start with, I make it a class, and only if I need performance, I go to value or primitive class. No, you will think through, well, what is it? It's a complex number. That's just a primitive value, right? So yeah, so let's make it a primitive type. You will do that because it's the best design, and then you will get performance for free. So Valhalla creates value and primitive types plus universal and specialized generics. That gives us way fewer trade-offs between design and performance, which is good. We can, as I said, pick the design that we want without compromising on performance. We don't need to manually specialize. A manual specialization would be int stream and long stream and double stream, and I assume the person quit then, which is why there is no float stream. So this work has been horrible. And there is function, and then there is toInt function, and then there is operator, and then there is long operator, and all of that stuff. All of those classes exist in the JDK because, yeah, the performance is sometimes needed. Sometimes you need an int stream that actually can deal with primitive ints. But generics did not allow a stream of int that would actually work like an int stream. So somebody sat down essentially and created, instead of a generic stream of t, put int where t is, and then called this an int stream class. And this is a manual specialization, and Valhalla gives us a lot of hope that those will no longer be needed. Essentially, what could happen maybe would be that the int stream interface just says interface int stream extends stream of int, and then it's empty. And not entirely, because there are a few methods on there that belong there, but basically the goal is everything else all the code that was written in InStream, or the InStream implementations, I should say, all of that code is just automatically generated now with specialized generics. Let's hope for that. As I said, we get better performance, not only because we can make performance-sensitive decisions without compromising on design, but also our dependencies can, right? If I use a machine learning library, if I use an image manipulation library, if I use something that does a lot of math, all of that kind of stuff that in the past would maybe create a lot of garbage and use a lot of objects with indirection, now they can refactor to use like the good primitive types and value types, and I get that performance for free. I'm really looking forward to that. Same in the JDK. I'm pretty sure that there's code in the JDK that can be rewritten with value types and primitive types and become both more maintainable and faster. We can design, as I said, express our design more clearly. And I hope that the result will be, or one result will be, more robust APIs. The last point is a little bit more guesswork. It's my personal guess. It hinges on the idea that if we pass immutable objects back and forth between parts of our system, there's much less shared mutable state, and shared mutable state is a huge source for bugs. So if you have two subsystems that cooperate by passing along like mutable user instances, and one subsystem changes the user and the other one doesn't know, that's where bugs come from, or one place where bugs come from. But if they pass along a value class user, which is by necessity immutable, then they cannot share a mutable state, or they don't share a mutable state, and then there would be much less risk of a certain category of bugs. So overall, makes Java more expressive and performant. When will that happen? Look, I don't know. I'm really hoping that we will see something in 2023, and I'm pretty sure that value classes will be the first thing. But honestly, I just don't know. There is this one is, as I said, is the most lofty of the projects. A lot of time has already been worked on that. There's a huge amount of effort that has been made. So I'm pretty sure it will come to fruition at some point. And I think it is around the corner, given that it's already 8.5 years old. But around the corner might still be 3-4 years. But I hope it's not. I hope we'll see something this year. And yeah, I think value class preview is the obvious first step. Let's see whether I'm right. But I'm pretty sure that specialized generics will be the last step, because it's the most complex problem. These are the best state of documents that I can recommend. State of Valhalla, the first two specifically are well understandable. The last one, you need to understand the JVM. As I said, I don't, so I struggled with that one. But the first two are just a great explanation. It's not an easy read, so maybe don't do it at 10 p.m. at night. But I'm pretty sure most of you will be able to get through that with a bit of focus. Okay. Questions about Valhalla?
I don't see any question, but I have one again, Nikolai.
Go ahead.
So it's about the primitive classes. So the primitives that we have right now, let me say the basic primitives, will be migrated to primitive classes, or are we going to have them as they are right now?
You're asking all the right questions. Remember that I skipped that part where I talked about these boxes here that just like there is integer for int, there will also be a box for the custom types that we create. Right. So here's the cool part. Once that functionality lands, we can actually apply that to the pairs that we had, like int and integer. And so the plan is we want to adjust the basic primitives like int, double, etc., to behave as consistently with new primitives as possible. So the idea is on the example of int and integer. Instead of int being something special in the JDK, and then, well, it will still be special, like you can't entirely get rid of it, but you can lessen that. And then integer being the class it belongs to, which has all the methods and all the functionality. Instead, int will become a primitive class that takes on all of that functionality. And then integer will become the automatically created box around it. And that box will then be aliased with the term integer. And then the class integer can basically be kicked out. So that means that, yes, they will align with this. They will use this concept. And the cool side effect of this is, by the way, that int now has methods. So you can now write 5, or well, not now. You will be able to write in the future, hopefully, 5.toString, for example. Because 5 is an int, and in the past, primitives did not have methods. But now a primitive will become a primitive class. So it can take on all the methods that belong to the wrapper class in the past. So the code will still exist, will be a different source file, basically, and will thus apply to both int and integer, not just to integer. Right, so yes, so the old primitives will be hopefully migrated to this approach. And that also shows how high the commitment is to get the same performance. Because if the custom primitives would have, let's say, only 80% of the performance of the current primitives, which would still be impressive, right? That's pretty good. Like, there's a huge gulf between the numeric performance you can get out of a class that uses references, like your own complex number class you write nowadays, and just using the primitives directly. There's a huge gulf there. And if you could get like all the way up to like 80%, that would already be pretty good. Like, we'd already get like a decent performance improvement. But if then this migration would happen and all the ins would suddenly be slower by 20%, that would be an issue, right? Like, then, I mean, you might get ahead on average, but a lot of code would just get slower. That would not be good. So this can only be done if the performance is actually really, like, the performance is that close. So I'm really looking forward to seeing how that turns out.
Thank you.
Okay, before I get to the last project, I want to talk to you about a few of the other things that are going on, and also come to the question about Java 8, if the viewer is still around. So first of all, it's not just the big projects that are being worked on. Lots of APIs will get added and changed. So we got a new random generator API in Java 17, an address as a resolution SPI in JDK 18. Java can now talk to Unix domain sockets, which, funnily enough, now also work on Windows, which is why it was introduced in Java 16. Unix domain sockets are a way to communicate on the same host. So if, for example, you have different services that communicate via the network, that's okay. If you have both of these services on the same machine and they use like the local host to communicate with one another, that's also okay. But you pay in performance and security for that, because you go to the entire network stack, and security because you do open a port. So with domain sockets, you're using the file system to transfer data. And that's both faster, because there's no network stack in the way. It's safer because it's not exposed to the outside of the machine, hopefully. And actually, like, it uses file-based access, file-based permissions, which are very well understood. So that's why you can probably, tie them down pretty hard. So, right, and Unix supported them since day one. Probably, I don't know when exactly, but that's long in Unix. And Windows, I forgot the specific versions, now also supports that. And that's why it makes sense for Java to support that. So if you have inter-process communication on the same host, switching to Unix domain sockets will give you more security and more performance. And then there are tons of small additions to all kinds of pre-existing classes, internal refactorings. These APIs are constantly being worked on. We also get continuous improvements to stuff like usability. There's a simple web server now. UTF-8 will be accepted by default. Null pointer exceptions became more helpful. There is the whole JFR story, which went from, I think, a proprietary product back in the days to like now a fully open source part of the OpenJDK, which gets continuous improvements. On JDK 17, event streaming was added. So when, JFR's Java Flight Recorder, it's a way to observe what's happening in your current system. And since JDK 14, you can actually observe it on a different machine. You have a Java system running here, and you can tell this one, okay, connect to that and give me all the profiling information. It's very low overhead, so that's good. And JFR scrubbing allows you to define filters so that, for example, if you dump, it's basically like log filtering, where you want to make sure that you don't have sensitive data in your log. That's what was added in JDK 19. Very cool as well. Code snippets in Java 18, in Java doc since Java 18. So if you're writing Java doc and if you put an example of how to use the API in Java doc, which I highly recommend, I think that's a cool way to learn a language, to learn an API. Read through the Java doc in the middle. Oh, that's how I use it. That's pretty good to know. That code in the past was just text. It might compile or it might not. Maybe it runs, maybe it does the right thing, maybe it doesn't. Who knows? It's just text. Nobody knows. What you can do now is you can put that stuff into a separate source file. You can then tell your build system to compile it. If you want to go the extra mile, you can even test it, that it does what you think it does. And then you just pull a couple of lines, the lines you want to show, into the Java doc from an external file. It's very, very cool for those of us who are fans of good documentation. Performance continuously improves. All garbage collectors, G1, Shenandoah, ZGC, Perl GC even, all of these garbage collectors get continuous improvements. But then there's also class data sharing, which improves the launch performance by let's say 15 to 30%, depending on the kind of app that you have. So if you're looking for a bit of improvements there, you should look into class data sharing. Security always gets improved. If you're interested in security, go to Sean Mullen's blog. Sean Mullen is in charge of security in OpenJDK, and he writes one blog post every 6 months on the day or the days after the new JDK release, and it goes over all the changes that were made, security relevant changes that were made since the last release. Once again, highly recommended. But we're not only adding stuff also gets kicked out. Stuff that is the requirements for what gets removed is not its old technology. Yes, nobody writes, hopefully, AWT anymore. But first of all, it's the basis of Swing, so you can't even remove it. But even if it doesn't hurt, don't remove it. That's not what's happening here, right? So it's not like OpenJDK members are taking a shotgun to the code base and just kill random stuff. The requirements for something to be deprecated for removal is that it hinders further development or has an otherwise specific negative effect on the ecosystem. And that's what's happening here. So as I said, like, this is the list of the 5 things that are currently being that are deprecated and that will be removed in a future release. You should definitely look this over. You should look at the JEPs. You should be sure that you are aware of this, that all of these offer one way or another to verify whether the code that you wrote or your dependencies code is ready for these changes. And as I said, I can recommend to be aware of it, to try out whether your code is ready and whether your dependencies are ready. And when your dependencies are not, open an issue, hope for them to fix it. If maybe consider providing your own pull request. Definitely look those over. And if you're not on Java 17 yet, then some of these things that to me lie already in the past, to you are still in the future, meaning there's a bunch of stuff that not a bunch, these 3 things: concurrent mark sweep collector, Nashorn, and RMI activation, that are already removed from the mainline, but might still be present in the version that you're using. So now is not a good time to add code that relies on RMI activation. Now is not the good time to further optimize concurrent mark sweep garbage collection if you're planning to update soon, because you'll soon be sitting on a Java version that doesn't have it anymore. So talking about migrations and updates, how do you improve your situation to make that easier for you? So I have a bunch of tips here. They're all easy to write on a slide, and I understand they're not at all easy to follow in everyday development. I understand that. I still want to give you those sound bites, basically, because we don't have time to go into too much detail, so that you keep this in mind, and that when you make a decision that goes contrary to one of these recommendations, that you should at least be aware of it and should be sure that you're getting something for it. Or ideally, you realize, oh, wait a moment, maybe I shouldn't do this after all. So first of all, only stick to supported APIs. That applies to the JDK code, 100% hands down. Don't use internal APIs. If some library tells you to add open something or add export something, become very, very doubtful about what's happening here. They might have a good reason, but they might also not have a good reason, and it runs the risk for your application to, in a future Java version, to stop working, and that makes updates harder, right? Like if your dependency uses an internal API that is changed between Java 14 and 15, then that keeps you from updating from 11 to 17, and that sucks. Not only stick to supported APIs, only stick to the behavior that they promise. Sometimes you're not sure how an API behaves, and it's very, very I want to say easy or tempting to just try out how it behaves and then bet on that. And then, okay, that's what I'm going to understand, that we're going to accept now. And that's good in many situations. But when you start piling a lot of code onto, does it behave like this or like this? Maybe make sure which of these behaviors is promised by the API, because sometimes it isn't. Good example is the iteration order of a hash map. If you put stuff, or a hash set, if you put stuff in there and iterate over it, then the iteration order is not guaranteed. It can be like this on one machine, like that on one machine. You don't want to accidentally depend on the iteration order and then it works on my machine but not on production. Now with HashMap, that's unlikely, just because it's very unstable actually. But there are situations where the API does not promise you something, but it behaves one way for years. The Reflection API did that in the past about the order in which it returned methods. You ask the Reflection API, what are the methods in that class? It will always give you them back in the same order, but it never promised that order. And then implicitly, some projects started to depend on that order. When it was changed, I think in Java 7 minor update or something, because the machinery behind the reflection API was changed, and so it started returning the methods in a different order that was never promised the original order. Still stuff broke, right? Okay, long story short, supported APIs, standardized behavior, and well-maintained projects. If you have the chance, if you pick between different dependencies, do consider a lot which of these you trust to be around over the years that you expect to run your project. Sometimes you don't have a choice. Sometimes the only solution is a project that just one person maintains in their free time in their garage. Well, first of all, consider supporting that person financially to make sure that they can maintain this in the long run. But if you have the choice, maybe stick to projects that you know will update with recent Java versions, will incorporate these deprecations and these removals that I mentioned. Keep all dependencies and tools up to date. I know this is a recurring struggle for many projects because this costs time. And if there's pressure to produce features or fix bugs, then updating dependencies often doesn't make it make it high to the list. Now, I think this is important. There's a difference between something that's urgent and something that's important. Updating dependencies is rarely urgent. It becomes urgent very, very fast if you have like, a log4shell situation where you suddenly realize, oh, dang, like now we have to update. Can we? Sometimes you have to update to a version that maybe has some change in between. And now you're in a security vulnerable situation where you have to update a dependency, but you also have to change code to make that update. That's not good. That's not good for a security point of view. But also overall, if you have the dependencies and tools up to date, the effort of updating is smaller, right? Like making small update steps is easier than taking large steps. So it's important to keep dependencies up to date, but it's often not urgent, so it often gets crowded down the list. If this is a situation that occurs in your project, try to speak with the team, with your leaders. I'm not sure, depends on how the project is set up. And really try to find a way to spend some time updating everything that you're using during the regular development process. Just make sure that you're always on the recent versions of whatever you're using. And if you notice that you can't, because maybe you go from Spring Boot 2 to Spring Boot 3 and the backwards incompatible changes, I'm not sure whether Spring Boot does that. It's just an example. Notice that early. Find that out the day 3.0 releases or even before, because you tested against the milestone. Make a burn down chart where you said, okay, so if these 10 places we need to change before we can update, work on those week by week, make sure you're making progress, then update the dependencies. Don't sit there with long outdated dependencies. And if they are always up to date and you stick to well-maintained projects, you have a very good chance that even the minor changes that are like removals that I just mentioned, that they will be immediately picked up by these dependencies. You can pick the new version and then you can go to the new Java version soon. Helps you with updating to new Java versions, but also helps you with everything else in the development process. Stay ahead of what's happening by visiting talks like this, by following the OpenJDK mailing lists maybe, but I want to highly recommend the tool JDepreScan. Use JDepreScan. It's a command line tool on the bytecode that you create, on your dependencies bytecode, and it will list the deprecated APIs that you're using, particularly the ones that are fit for removal. So, for example, that could be something that once every night you run JDepreScan over your code and all dependencies. It creates a little output. You can play with that output and maybe create a report. In the morning, you see, oh well, we added one more deprecated API was used. Maybe because you used a new dependency or because somebody wrote that code. Track that. Make sure you know that it's happening, and ideally work towards that number going to 0. And as I said earlier, build on each release. So let's say you have a large project which consists of, let's say, 50 Maven modules. It's not that large, but let's say, right? So on your daily process, you create like 50 jars. You're building on Java 8, say. And you try to build on Java 11, and you had some issues. 5 of your projects wouldn't build. Okay, not great. But, the other 45, build them on Java 11, maybe every night at least. Not for every pull request, maybe. But why not every night? To make sure that if a 6th project now suddenly doesn't work on JDK 11, that you at least find out. And don't stop at 11. I would recommend use the version that you're currently baselining against. Use every LTS version after that. So at the moment, there would be, say, 8, 11, 17. Also, the newest release, so at the moment, it would be 19. And the newest EA releases, that would be 20 and 21. So yes, what I'm basically saying is, whatever you're building, let's say you're on Java 8, whatever you're doing there, whatever build matrix you have for 8, also do it on 11, 17, 19, 20, and 21. Yes, that's a big build. That's why you maybe only do it at night. But then in the morning, you will see what's going on, and you will learn very, very early if there are some things that might cause problems in the future, right? Imagine being in a situation where something is deprecated for removal and maybe is already removed, but in the Java version you're using, it's still there. You're still piling code on top of the applet API, say, and it's gone after an update. And you could have prevented all that extra work being wasted by just finding out earlier. Okay, if you follow all these steps, and as I said, they're not easy. They're easy to write, not easy to implement. Then you can also benefit from whatever these projects that I already showed you, whatever they deliver as soon as they come out. Now, usually by show of hands, I ask people who use Java 8 or 11 or 17 even, sorry, or 17 or the newest versions. And what I usually get back is that Java 11 has overtaken at this point, I think, Java 8. Now, it's very hard to say, because if I ask people like you or people at the Java user group or at a conference, those are self-selected people that are interested in more modern development, right? So there's clearly a bias. So I have no idea how strong that bias is. So I can only speak to the people that I ask at conferences. 11 is ahead of 8, and not by a small margin. The only reason why sometimes 11 is behind 8 is because everybody who was on 11 already moved on to 17. So that's actually an interesting thing to notice. 8 to 11 can be a challenge, particularly on large old projects. That can be a challenge. But from 11 to 17 is usually much easier. So most of the people who made the more difficult step to 11, they now just moved on to 17. And many of those who are still on 11 are considering it. And then usually I get just a few people using the latest version. And I hope those people become more common, because I think that would be better for these projects for a variety of reasons. And I hope that people who went from 11 to 17 and noticed that it wasn't that hard, even though it was 6 versions, will trust themselves to be able to do 1/6 of that every 6 months. Also, the next LTS version is 21. So the way, let's say the way between save points became shorter. And now the question was earlier, what to do with projects that are only on 8? What about newer Java versions? How do you get there? I already mentioned a bunch of things that you can do, right? So if you are on 8 and you want to at some point update past 8, one thing you can already prepare that now is by making sure dependencies are up to date. Now, we are still in a nice little beautiful moment in time where I can tell you, just make all dependencies put all dependencies on the newest version and then update. Because there are very few projects that already require Java 11 or 17 on the latest version. Spring Boot 3 is actually one example, and Spring 6 as well. So at the moment, you can just look at your code base, update all the versions, or almost all the versions, to max. I know that might not be easy, but that's what you can technically do. And then you can probably upgrade to Java 11 from 8. Now, in a couple of years, the newest versions of all of these libraries, some of them will already require 11. So you cannot first update and then go to 11. You either do it in one step, which makes everything more complicated, or you have to figure out which combination of dependencies still works on 8. Don't go there. Right? At the moment, you're, as I said, this beautiful spot in time where almost everything still works on 8, and almost everything that works on 8 also works on the new Java versions. Take this opportunity to update now. Other arguments would be, do you expect your project to still be around in 10 years? I mean, if not, great. But if yes, you have to update anyway eventually. So if you're in a conversation with somebody who, maybe may call the shots on this, maybe a tech lead, an architect, or, maybe manager who you cannot convince, you can ask the question, look, if you think this is too expensive now, what makes you think it's less expensive in 5 years or in 10 years? And if it becomes more expensive in 5 or 10 years, what, we just let the project die in 10 years when nobody supports Java 8 anymore? Or we start paying the big bucks for this super old long-term support? Why? I think most projects can do the step now, and there's plenty of arguments that you can bring to your tech lead or manager. The other, maybe another good way to address this with somebody in management would be, ask them whether they struggle to get new developers. Many companies do, right? Many companies have struggled with hiring developers. Ask them what they think, what would be easier to hire a developer for, a 10-year-old language or up-to-date language. Meaning, if you sit there and you want to get this person who sits in front of you in the interview to come work at your company, Tell them you work with Java 8 or tell them you work with Java 19. All other things being equal, that person might prefer the Java 19 place. I mean, sure, that's not the only thing that matters, but it surely does matter at least a little bit. So that can also be a nice side benefit, that you can just find it easier to hire people if you can demonstrate that your tech stack is up to date, that you're using Spring Boot 3. I just pulled Spring Boot as an example because it just came out. Whatever dependencies you use, the JDKs you use, the IDEs, the tools, that you at least use all of that in the newest versions, and nobody has to be afraid to come to you and then work in, I don't know, Spring 4 or something. Okay. Project Loom. That's the last step. I took so much of your time already. Holy, it became very late. I'm very sorry for that. Right. So I'm going to give you a super short Loom introduction to not take more of your time. There's great videos by my colleague Jose Pomar on the Java YouTube channel. I'm going to show you that later as well, and then you can follow up there. So let's talk quickly about Loom, and then let's wrap this up. Okay. So let's talk about a hypothetical HTTP request. You're writing a backend, and what happens is there's a request coming in. You want to take the JSON or whatever it is apart, understand what you need to do. You probably need to query a database. You do that. You wait a couple seconds. No, well, not that long, hopefully. Let's say a couple milliseconds for the database to reply. You take the database response, put everything into the HTTP response, and send it down the line. How well do you use your JVM resources? Step 1 and 3, memory is busy, CPU is busy. It's great. Step 2, nothing happens. You're blocking some resources, but the JVM itself doesn't make any progress. So that's not great. How do you implement the request? You can do it synchronously. Your application has a unit of concurrency. Your application needs to concurrently handle a request. That's the unit of concurrency of your application. The JVM offers you a unit of concurrency, which is the thread. You want to do things concurrently, use threads for that. So the obvious approach is one thread for each request. That's basically the entire ecosystem. Well, not the entire ecosystem anymore, but a lot of the tech stack hinges on that. It's simple code, it's simple to write, to debug, to profile. All of that works very good out of the box. But the issue is that you block threads on certain calls. And the number of threads is limited. Default threads in Java, let's call them platform threads, are basically just a thin wrapper about an operating system thread. And that's somewhat expensive. In the order of about a megabyte for each thread. You can have thousands, but you can probably not have millions. Somewhere in between, there's a line. And platform threads might just be the limit. So you might be in a situation where you cannot have more threads, but still so many are waiting that your CPU just sits there and does nothing. And that gives you bad resource utilization and potentially low throughput. Not automatically, depends on the shape of your system, but that's a good chance. And some people had the revolutionary idea to, you know what, maybe if threads are such a limited and expensive resource, relatively speaking, maybe we should only use them if we actually need them. Crazy, I know. And the approach to do that is to use non-blocking APIs with futures or even with reactive streams. But this is not anymore aligned with how the platform was developed for concurrency. So this code is harder to write, but particularly it's very challenging to debug and profile. It's also incompatible with synchronous code. If you have a library that doesn't know about the reactive stuff you're doing and it just starts blocking for whatever reason, that's not good. But if it all works, it's great. It gives you you share the platform threads across all operations that are currently busy. All the waiting ones can be waiting. You can have way more waiting operations, and thus gives you better resource utilization, higher throughput, which is good. Which puts you at odds between the simple code you want to write and the high throughput code you need. And this is a theme, right? Valhalla gave you the tension between performance and design, or tries to fix that tension. Loom wants to fix that tension between simplicity and throughput. Panama wanted to fix the tension between safety of memory access with the performance that unsafe had. So often what these projects do is not as I said, like a marginal improvement in writing the code or syntax. What it wants to do is resolve these underlying conflicts. Okay. Virtual threads enter the picture in Project Loom. A virtual thread is like a regular thread, has a very low memory footprint, and it's managed by the Java runtime, which gives it very small switching cost. Most importantly, it requires no operating system thread when waiting. So you can have a lot of virtual threads. How does it work? There's a dedicated pool of carrier threads, that's what we call them. And when a virtual thread is doing stuff, it is mounted onto a carrier thread, and the carrier thread is basically doing the work, and the virtual thread is thinking it's doing the work, but it's not. And in the moment the virtual thread blocks, the JVM takes these two apart, or not the JDK, right? The runtime takes it two apart, parks the virtual thread somewhere in memory, and gives the carrier thread back to the pool so it can start working on something else. So how does it work in this hypothetical request from earlier? To interpret the request, so when the request comes in, the runtime submits the task to the carrier thread pool, and then pretty soon, hopefully, it gets picked up and you work on step 1. And when you enter step 2 and you block, the virtual thread yields. And it thinks it's blocking. If you look at its stack trace, it's sitting in a blocking situation waiting for the database to return. But the carrier thread pool, as I said, is going back to the pool and it's doing something else over there. And when step 2 unblocks, the runtime notices, takes this task, submits it to the pool, and then later another carrier thread comes along, takes that virtual thread and completes that task. And the whole time, the virtual thread says, I'm just blocking. The code you wrote doesn't know anything about the shenanigans. The code you wrote just says, I create the database, I block, when the result comes, I write the code. A very pointless example here where I create 1 million virtual threads and then for each of them just wait a second. The joke I try to usually make at this point is virtual threads can wait at infinite throughput. Basically, you can have basically infinitely many threads sleeping at the same time. That's of course pointless. Why would you want to sleep? But what I'm trying to show you is that a virtual thread is so cheap that you can easily have 1 million of them just sitting doing nothing. Okay, I'm not going to go to the more complicated examples, as I said, for time reasons. Right, so still there are deeper dives at the end of this section too. So if you do have the slides, go look up at that. There's a bunch of more stuff here. But the other thing that I mentioned is the stuff that we at the Java team at Oracle create. We have dev.java, which is facing, developer facing. If you have a colleague who maybe is new to Java, if you want to look something up about how the module system worked, there's a bunch of good stuff there. Stream API is there as well. There are basics like how to operate with strings and something. So a lot of good stuff on dev.java. If you're interested in this talk and this kind of what are the cutting edge projects doing, go to inside.java. Inside.java is an aggregator of all kinds of news happening out there in the OpenJDK, and it picks up those news and gives you just the good ones, the important ones, so you don't have to wade through hundreds of mailing lists, not hundreds, but dozens of mailing lists. You can just get the important news there. And then also follow at Java on Twitter and go to youtube.com/Java. This is what I mentioned earlier. If you go to youtube.com/Java right now, you will find the Jeb cafes in a list very close to the top. And there you can find the Jeb cafes from Jose Pomar on Project Loom. There are a bunch of them there. And he goes really deep, starts at the top, repeats a little bit of what I just said, and then goes way deeper, giving you a very, very good understanding of this specific thing. And if you're interested, as I said, to contribute, dev.java is a guide of how to get started. But if you just want to follow along, github.com/openjdk, everything of this happens out in the open. You can follow along there. And with that, I'm finally ready. I did not expect this to take so long. I blame the questions. I'm sorry.
Good point, Nikolai. So, by the way, there is no question for the last part, but I want to mention also, I like the ease migration slide for the governance of the code, especially that you are writing and you are managing. So it's really important for all of the developers who are, let me say, Java developers who are planning to migrate from Java 8 to Java 17 or 19. So it's really a beneficial slide. I took notes also over that, especially about the well-maintained libraries and the dependencies. So thank you. I don't know if I'm just also giving some time for the attendees to ask questions, but I think there is no.
Yeah, one more note on the thing with well-maintained libraries. Of course, sometimes that just doesn't work, right? Sometimes you're in a situation where, specifically if you're in a small niche where there are not many libraries doing what you want, then you just have to pick the one that's there. But then also do consider whether you can support that person or that team working on that, right? So often like we're used to open source being free, and if you use one of the large projects, they have a way to monetize that, right? So they do have professional developers working on that, and that's kind of okay, I guess. But it's well, not that is okay, period. But it's a bit weird that sometimes large and like rich corporations, you create products or projects that hinge on the work of somebody doing that right on the weekends and late at nights, without supporting that person at all. And I think so when you realize, like, wait a moment, I'm betting a lot on this one dependency, it's really important to me, but it's not that well maintained, there's a good chance that the person working on that project actually wants to maintain it better. And I don't know, 50, $100 a month are probably not going to make that big of a difference. That's not going to allow them to then work on that full time. But it's a start. And if more companies do that, if more projects do that, to look through the dependencies and support them, not only will it make the ecosystem as a whole better, I think, it will also give you more safety that this library is actually getting maintained, that you can still, use it 5 to 10 years from now when your project is still around, but that person might otherwise already have moved on.
Exactly. So thank you, Nikolai, for this presentation.
Thank you.
And thank you again accepting. It's very beneficial for all of us. And thank you for all the attendees to be here with us today. So Thank you.
Yeah, thank you too. I had a great time. Sorry for running a bit long, but I had fun. I hope you had too, and you learned something. And I hope to see you in person.
Yeah.
Good.
I want to also. Yeah. So see you. Thank you again. Bye-bye.